In the last video, we created a more efficient system for handling feature toggling by creating a lock list that would capture incoming lock signals. Let's go ahead and create a more formal definition for this lock list that we can use in future projects. So here I have a new script called LockList, and I'm going to define it as a constructor object. I will begin by creating a private section, but before we put any code in our private section, let's go ahead and define what our public methods should look like. I'm going to define a method called static setLock, and this method is going to take a lock name. I will also have a remove lock and an isLocked method. So if you remember in our previous video, all we did was store these lock names into our list, remove them when we no longer needed them, and then we had some way to check to see if we could validate the feature toggle. So these three methods should be more than enough to get us started with what we need. We know that we want to call setLock and pass in a lock name, but the question is, how are we storing this and how do we want to manage it? In the previous video, we just used an array. So that implementation would look like this, where we would just create an array called locks, and we would say array push locks of lock name. And we would go and do everything that we had done previously. However, I want to be able to add some more functionality to this and potentially grow this system in the future if I find a new idea that I would like to add on. So instead of storing these as an array, I'm actually going to store this as a struct. And I'm going to additionally create a new class called lock. So here I have a new constructor class called lock, and this will be a subcomponent to our LockList class. So let's go ahead and start by creating a private section once again. And we know that these locks are going to have at least one parameter, and that is going to be the lock name itself. So let's go ahead and give it a name. And I will add some public methods called getName and setName. So now let's come back to our LockList class. Now when we say setLock, we aren't storing this in an array anymore, so we need to store this into our struct. Additionally, I want to utilize this new lock subclass, so the easy way to do that is to just create a new lock instance and store that in our struct using our lock name parameter. Locks of lock name is new lock. And we also want to make sure that we pass this lock name down into our lock. So let's go ahead and store that in our config struct. So this is starting to look good, but we will notice that if I have a lock already stored with this lock name, that we will create a new instance and overwrite it. So let's first make sure that this lock doesn't already exist. We can do this by saying if not variable struct exists of locks of lock name, then we will go ahead and create this. Okay, very cool. So let's go ahead and implement our remove lock functionality. So first we want to make sure that this lock does exist. So we'll say lock is locks of lock name. And if lock is not undefined, then we can go ahead and remove it from the struct. The last thing I'm going to do is implement our isLocked method. This is just going to say return variable struct names count of locks is equal to 0. So I really don't like using this variable struct names count runtime function. There's several reasons for that I won't get into, but to simplify it, in order to remove this function call, I'm going to also add a new private member that will keep track of the number of locks that we have. So I will say size is 0. And now when we add a new lock, I will increment size. And when we remove lock, I will decrement size. Now I can replace this by saying return size is equal to 0. Great. This is a functional lock list system. This covers everything that we did in the previous video and does so in a pretty well-structured manner. But one thing that I showcased was the ability to lock our locks for a set amount of time. And this can be really useful for things like debuffs, items, or any sort of dynamic gameplay feature. So let's go ahead and add this new functionality. The way I'm going to do this is I'm just going to add a new parameter to our setLock method. And this new parameter is going to be lock time. Now I want this time feature to be optional. And so in order to do this, I'm going to default this time to -1. So if the time is -1, then we store the lock indefinitely. But if the lock time is passed in, then we will have a timer that will run in the background and will automatically remove that lock once that time has reached 0. So in order to do this, let's go ahead and add a new member to our lock class on the right side. And I'm going to say time. You could call this duration or life, but I will just call it time for simplicity. Now I'm going to go ahead and pass this in when we instantiate. So here what I've done is I've passed in the lock time parameter, and I will pass it down into our new lock class instance, and I will store it inside of our lock class. Now all we have to do is handle updating this timer. So this means that we need some sort of update functionality in order to make sure that this lock list is ticking every frame. So inside of our lock class on the right, I'm going to go ahead and add a new public method called static updates. Now this is a public method, but I am throwing it at the bottom for reasons I won't go into in this video. But if you are interested to learn more about this, I recommend you check out my other video on custom events in constructor objects. But for now, I'm just going to throw this event method at the bottom of the class definition. So naturally what we want to do is, well, we just need to update our time member. So when update is called, I'm just going to say if time is greater than 0, then we will decrement time. Else, if time is equal to 0, we will set time is equal to -1. So now we need to remove this from the list that it is stored in. Currently, the lock instance has no awareness of the lock list that holds it, but we can change this by adding another member into our private section. List is equal to config of list. By default, this will be undefined. Now, when we set the lock, all we have to do is just pass this reference in. So we will say list is self. Now, sometimes this self reference can get a little messy, especially when calling it from inside of new anonymous struct instances. So in order to just avoid this messiness, I'm just going to capture a reference to the lock list instance outside of the new lock instantiation. So I will say list is equal to self. And now inside of here, I will say list. So now that means when our timer has expired in our lock class, all we have to do is just say private of list remove lock of name, because we are just going to invoke our public method called remove lock from inside of the class. Now, the last thing we need to do is just make sure that we call this update method. So this update method exists, but it's not being called. And to do this, we're just going to have the LockList parent class call this update event. So I will go ahead and create a update method for the LockList class. And inside of this, all we need to do is just iterate over all of our stored locks and call update on them. So I will say var of names is variable struct get names of locks. And then I will create a for loop that will iterate over this. First, I will pull the single name from our array of names based off our index. Then I will grab the lock from our struct using this name. And now I will just call lock.update. I will also remove this variable struct get names method because I'm not entirely sure how this handles in the backend in terms of performance. So since I'm going to be calling this every single frame, if this tends to be a slower method, I want to avoid having to invoke this every single frame. So I'm going to do the same thing I did with tracking the size, and I'm just going to go ahead and keep track of the names of the lock as I insert them. So I will say names is empty array. Then when I set the lock, I will go ahead and push our lock name into our names. And then I will go ahead and delete it from our array when we remove the lock from the array. I'm going to use an iceberg utility method called iceberg array find delete. And this will just handle iterating through that list and deleting this member for us. If you are interested in seeing a video on how I handle this custom set of utility functions, leave a comment. All right, so now what I've done is I've just decided to manually track our names in an array when I add and remove locks. So now instead of having to fetch the names dynamically from our struct every frame, instead I can say names is our private member of names. All right, and that's it. We have just implemented a LockList class definition with a LockChild subclass and established the relationship between the two of them. And the great thing about this implementation is by separating out the logic into our LockList and our lock classes separately, we are able to continue to add functionality at any point in the future if we wish to have more functionality added. So in any situation in which you decide, hey, I would like to add this feature to my lock or my LockList, it's very easy to just expand and these class definitions to do so. So let's go ahead and show lastly how we would implement this, right? Because I have this custom update event. So I'm going to go ahead and collapse this. And once again, I'm just going to pretend that I am in some other object. Let's just say I'm in obj character.create. So here I would say LockList is new LockList. Now in our step event of our character object, I will just say LockList.update. You could also put this inside of a state machine, and I would highly recommend you do if it would be appropriate for your project. But we just need to make sure that we are calling this update method once a frame. So at any point, if I wanted to add a lock, I would just say LockList set lock, pass in some name, my test lock, and this would store our lock in our list. If I wanted to remove this, I would say LockList remove lock of my test lock. Or additionally, I could instead not remove it manually, and I could pass in this optional parameter in which I would only set this lock for 60 frames. Okay, that's it for today's video. Give the video a thumbs up, consider subscribing to the channel, and I will see you in the next video.